Linux Essentials, the BIOS and UEFI. In this session, what you will understand is what happens when you switch on your system, meaning the process of starting the computer. What happens behind the screen before you log into the computer. So in this session, I will cover the UEFI, GPT, that is GUID partition table, the boot process, basic system configuration, the UEFI menu, the bootloader, startup menus, the boot menu, and Linux bootloaders. The UEFI, which stands for Unified Extensible Firmware Interface. This specification defines an interface between an operating system and platform firmware. Why it was needed and what is it actually in simple language? Earlier we could have maximum 4 disks, and in one disk we could have 15 effective partitions. But as we are growing, as we are innovating, we need more options for addressing more disk, more partitions in the disk. Partition is a logical division of the disk. So therefore, from where the operating system can be loaded, because ultimately the operating system will be in the hardware. Firmware is the software version in the form of hardware script or hardware program. This firmware is responsible for loading the operating system, and the problem with this firmware was it could address only 4 disks, not more than that. So to address this issue, we need something in between so that we can have more options and we can load more operating system from more disk. Of course, we will load only one at a time, but the facility wise, we need at least more. So UEFI, it defines an interface between the operating system, this is operating system, and the platform firmware. The interface consists of data tables that contains platform related information. We are talking about this EFI or UEFI. Boot service calls to load the appropriate operating system, and runtime service calls that are available to the operating system and its loader. Every operating system, first before you start working on it, needs to be loaded into the memory, and after it is loaded from the disk to memory, take control of your computer. It allows you to interact with the computer, allows you to work with the computer. Operating system is the first thing to be loaded. That's the important point. And what all operating system, if we want more operating system and more options, then UEFI serve that purpose. These provide a standard environment for booting an operating system and running pre-boot applications. Pre-boot means before the computer is booted. Booting by definition is the process of starting of the computer. The GUID partition table, it appears too technical, but it's not. I will explain that. I'll make it simple. GUID partition is a new disk architecture that expands on existing MBR partition scheme. MBR stands for master boot record. This is the scheme which I was referring, that it could have only 4 disks supported, and to allow more partitions, this partition table is created. Partition table is like index of your book. I'll try to make it easy to understand. Imagine you have first page, only one page available, and in this page we can have 55 lines, and each chapter you want to mention that need one line, which means that you cannot have more than 55 chapters in the book, as simple as that, because you have only one page to specify the address of those 55 chapters. So this partitioning table have 128 such entries. Look at this entry 1, 2, 3, 4. This is, think of it as an index of the book. So 128 partitions are supported, not 4. And this is the first part, that is because it is extension. Protective MBR is still there. The first, think of it that we have added extra pages for the indexing, extra pages for the mention or for the reference to the chapter names. So protective MBR is still there, but we can have 128 more entries to point to the disk. Think of them as chapters. Chapter 1, like entry 1 will point to chapter 1, entry 2 will point to chapter 2, entry 3 will point to chapter 3, and so on and so forth. And this partition table will be in the form of two copies, that is secondary GPT, same entry, duplicate entry, so that if something goes wrong we can use the another partition table. It is a copy. So this allows up to 128 partitions to be handled by this GUID partition table scheme. So partition is nothing but a logical division, as I said. Think of a section of a book or chapter of a book. It's a continuous space of storage on physical or logical disk that function as though it were physically separated disk. LBA here stands for logical block addressing, how the addressing is to be done. Very simple analogy I have given you, the index of a book and the chapters of a book. How many entries you can have index will decide how many chapters you can have in the book. What is boot process? Booting process is whatever happens from the moment a system is powered up to the time a login prompt or login screen is available. So much happened when you power on your system. So many things happen behind the screen when you power on your system. After installation of Linux, the BIOS or UEFI point to specific media device. Think of it as a disk. In case of a local disk, the GUID partition table or GPT or MBR of that device points to the GRUB2 bootloader. The loader is responsible for loading the operating system. Once an option to boot is selected in GRUB2, the associated commands point to an initialized Linux kernel. The kernel is a core of operating system, which then starts systemd, the first Linux process. A process is a program in execution behind the screen. Systemd process then initialize the system and activate appropriate system unit. Think of them as things which consist of multiple programs or group of programs where one program depends on another program, so it forms a hierarchy of dependency along with their directories and files. So this is called a system unit, and these units are activated. When Linux boots into specific target means what will be the environment when you boot. Is it going to be text based or CUI, or is going to be graphical? We have seen two different format, two different appearance of operating system Linux, that is GUI, graphical interface, or CUI, character interface or command interface. It starts a series of units because operating system is not a single file. It consists of multiple modules which are connected with each other, form a proper sequence, because you cannot have a sequence, I mean you cannot change the sequence. If part A or module A is needed by module B, the module A needs to be started first, and it must be mentioned that module B needs module A. Similarly, if there's some other module which is dependent on module B, that also must be specified that module C will be needing module B. So there's a hierarchy or dependency, and the unit consists of individual independent modules or such related modules, connected modules, that helps you identify, okay, this module will start this module. I'm using the term module to make it easy to understand. The real term is unit. The BIOS and UEFI. UEFI has replaced BIOS in many modern systems and can do so much more. But the UEFI support changes to boot media in similar ways. The functionality for our purpose is the same. A variety of UEFI software are available. It is not possible to provide any sort of step-by-step instructions for modifying this wide array of available UEFI menus. So when a computer is powered up, the moment you switch on your system, the first thing that start is BIOS or UEFI. BIOS stands for Basic Input Output System. The BIOS starts, Basic Input Output System start, and or the UEFI. You cannot have both. You have either BIOS or UEFI. BIOS is the old system, old mechanism. UEFI is new mechanism. Based on the settings stored in read-only memory, that is ROM, the BIOS system performs a series of diagnostics to detect and connect to the CPU and key controllers. Point is here, if you noticed a physical computer was CPU box, monitor, keyboard separately connected, you might have noticed when you switch on that computer, there's a blink of light on every device. This is called power on self test. Post. If you hear a beep during this process, when the blinking is happening, every device is verified. There may be a hardware problem, such as an improperly connected hard drive controller. The BIOS or UEFI system then looks for attached device like the graphic card. Once complete BIOS passes control to the boot device, the first hard drive in the sequence, how they are configured, which will have the operating system, which is expected to have the operating system. Operating system means the kernel. The first stage of the GRUB2 bootloader is normally copied to the MBR or the GPT, that is GUID Partition Table or Master Boot Record. It serves as a pointer to the other information from the GRUB2 menu. At that point, you should see the bootloader screen. The screen which you recollect, that black color where we have list of kernels listed. Sometimes you all see after the post is a blank screen. The BIOS is often configured in this way to show you blank screen, don't show you that menu. In that case, you need to do some guessing based on experience how to access the boot or BIOS menu. I demonstrated yesterday by pressing escape key. If you recollect, when you switch on the system, if you press escape key immediately, you saw that screen. That is the BIOS menu, if you noticed. The first part of bootloader, that is called stage 1, is installed in the master boot record or the GUID table of the default drive. Normally, the BIOS should automatically start the bootloader with a message similar to this. Like you see that different kernels you will see listed in order. You have 5 seconds time to select any of them using arrow keys, or E to add it, or C for the command prompt. E is to add it, C is to command prompt. If you press a key before the duration display is generally 5 seconds default. However, you can change it. GRUB will present a menu. If the system includes more than one Linux kernel or more than one operating system, you can highlight the choice using arrow keys To boot Linux from the highlighted kernel or highlighted option, you simply press enter key. That's what we did. Rocky Linux 9 supports traditional MBR partitioning layout and the newer GUID partition table GPT both. Whether it is RHEL or CentOS version 8 or 9, CentOS is replaced by Rocky now, therefore I am using Rocky. The MBR partitioning scheme support maximum size of 2 terabyte disk space. GPT does not have such restrictions, such limitation, so therefore you can have bigger and more size supported by the GPT partition table. However, to boot RHEL or Rocky Linux from a disk with a GPT partition layout, you need a system with UEFI firmware interface. If you recollect, when we installed that, we selected UEFI rather than traditional BIOS firmware. You should check with your hardware vendor if the UEFI is supported by your system. That's what we did yesterday. And that's all for this session. Thank you very much for watching.